All right, let's jump right in. We tend to think of getting oil as just drilling a hole in the ground, but getting all of it out, that's a whole other story, a massive engineering challenge. Today, we're going to look at a really ingenious solution to a very, very sticky problem, one that uses a simple little twist to get millions more barrels of oil out of the earth.
So, before we can appreciate just how clever the solution is, we have to get our heads around the problem. A pretty common technique to get more oil out is something called CO2 flooding. You basically pump carbon dioxide down there to push the oil out. Simple, right? Well, it turns out it has a pretty fundamental flaw.
I want you to actually picture this. Imagine you've got a thick puddle of honey on a plate, and you try to move it by blowing on it. What happens? The air just drills a little tunnel right through the middle, right? And most of that honey gets left behind. Well, that in a nutshell is the exact problem with CO2 flooding.
And this is why it happens. You've got this total mismatch of properties. On one side, you have the CO2. It's thin, it's light, it flows super easily. It's just like the air in our analogy. And on the other side, you've got this thick, dense, slow-moving crude oil. That's our honey. So when you try to push one with the other, that unruly CO2 doesn't create a nice, even push. It just cheats.
Now, if you want to sound like an engineer, here's the term for this mess: an unfavorable mobility ratio. It's really just a fancy way of saying the CO2 moves way, way too easily compared to the oil it's supposed to be pushing. And that difference in mobility is the real heart of the problem. The result of all this? Well, this quote nails it. The CO2 finds the path of least resistance, carves out a channel straight to the production well, and just pops out on the other side. They call it premature breakthrough. And what does that mean? It means you're wasting a ton of CO2 and, even worse, leaving a huge amount of valuable oil completely untouched, trapped in the ground.
So if gas alone is like trying to push honey with air, what do? How do you fix that? Well, it turns out you bring in a third player to completely change the game. And the solution is surprisingly simple, but really, really clever.
And here it is. It's called water alternating gas injection, or just WAG for short. The idea is brilliant because it's so simple. Instead of just blasting gas down there, you alternate. You inject some gas, and then you inject some water. It's a one-two punch that totally changes the physics of what's happening underground.
So the process is literally what it sounds like. First, you inject a pocket of CO2. Engineers call it a slug, to get that oil loosened up and moving. But, and this is the key, before that CO2 can go rogue and punch a hole, you follow it up with a slug of water. And then you just do it again, and again, and again.
Okay, but why does this work so well? What is the water actually doing down there to tame that unruly CO2? This is where the real engineering magic comes in. Let's break down the science of it.
The best way to think about it is that the water acts like a traffic cop. It gets in the way. It goes in and it fills up the easiest pathways in the rock, the superhighways that the CO2 is taking before. By blocking those paths, it slows the CO2 down, forces it to spread out, and makes it push the oil in a much more orderly, uniform way, almost like a piston.
All right, so we've got the problem, and we've got this really elegant solution. But what does that actually translate to in the real world? Let's take a look at the payoff.
The results, well, they speak for themselves. This chart shows you everything. On the left, that's what you get with just plain old CO2 injection. But on the right, with the WAG method, look at that. You see a really significant jump in how much oil you get back. It's not a tiny little tweak, it's a major leap in efficiency. Let's just focus on this number for a second. By switching to a WAG strategy, you can increase your total oil recovery by 5 to 15%. Now, that might not sound like a crazy number, but in an industry where 1% is worth millions and millions of barrels, that is a massive, massive gain.
And of course, this isn't just a case of randomly dumping water and gas down a hole. No way. As this table shows, it's a finely tuned recipe. Engineers are meticulously calculating things like the WAG ratio, how much water to use for a given amount of gas, and the cycle length, which can be weeks or even months long. It's all about optimizing it for that specific reservoir.
But the innovation doesn't just stop with alternating water and gas. You'd think that was clever enough, right? Well, engineers are now taking that same idea and pushing it to the next level. So where does this technology go from here?
Say hello to foam-assisted WAG, or FAWG. This is the next generation. In this version, they add surfactants, which are basically a type of soap, into the mix. This creates a really stable foam down in the reservoir,
which is even better at blocking those easy pathways and forcing an even more efficient sweep. It's the next evolution in controlling where everything goes.
You know, the whole WAG strategy is just a beautiful example of elegant engineering. It's solving a really complex physics problem, not with some bigger, more powerful machine, but by just cleverly combining two very simple things: water and gas. And it makes you wonder, doesn't it? What other huge challenges out there could be solved not with a single silver bullet, but with the right simple combination?